This presentation will review the Georgia Standards of Excellence 3 MD8, which focuses on recognizing perimeter as an attribute of plane figures and distinguishing between linear and area measures. 3 MD8 states that students will solve real-world mathematical problems involving perimeters of polygons, including finding the perimeter given the side lengths, finding an unknown side length, and exhibiting rectangles with the same perimeter in different areas or with the same area and different perimeters. First and second grade students begin recognizing and drawing polygons while also measuring length. Third grade students find the area of rectangles and understand perimeter as the distance around a polygon. And fourth graders then apply the perimeter formula for rectangles and find the area of composite shapes. As students explore and build shapes, they soon discover that even if the perimeter stays the same, the area of the shape may change. These rectangles have a perimeter of 18, but they have different areas. When counting the units in the perimeter, students need to make sure that they count the edges of each unit and not just the units themselves. In the upcoming videos, you will see how students design pens with a perimeter of 24 feet for their dogs. The students used a model of their choice and shared the results with classmates.
Hi, I will be showing you the perimeter I made with 24 pretzel sticks. There's 5 on this side and 5 on that side. Then there's 7 on this side and 7 on that side.
There is many ways you can build a pen with a perimeter of 24, but today I've only done 2. So then to find the perimeter, we have to do the length plus the length, which gives us 16. Then we have to do the width plus the width, which is just 8. So 16 plus 8 is 24. If we do this one, see, the length is 10 and the width is 2, so we would do 10 times 2. And 10 times 2 equals 20. That finds the area. But then to find the perimeter, we have to do the length plus length, which is 10 plus 10, which gives us 20. And then we have to do the width plus width, which is 2 plus 2, which gives us 4. So our perimeter is 24.
Students also explored how even if shapes have the same area, their perimeters can be different. Both shapes have an area of 6 units, but the first shape has a perimeter of 14, and the second shape has a perimeter of 12. An engaging way to explore this concept is by showing these images. Ask, which shape do you think has a greater area? Allow students to discuss and debate. Then give every student a 3x5 index card and ask them to cut it in half diagonally. Have the students create as many designs as they can by connecting sides that have the same length. There are 6 possible designs. The area remains the same even though the shape and perimeter changed. To explore this concept further, students use Nearpod to design different chicken coops with an area of 24. While the area stayed the same, the perimeters changed based on the arrangement of the tiles. Nearpod that was used for the chicken coop task is a digital platform that allows educators to design and create lessons that can be directed live in a classroom setting or assigned as self-paced activities. A variety of activities can be incorporated, such as videos, quizzes, games, and whiteboards. Submission reports can then be downloaded to analyze student work. Another engaging way to integrate technology in student discourse is by using Flipgrid. Students were posed with a problem that stated, would you rather have Cheez-Its that cover a rectangle with the length of 9 and a perimeter of 22, or a length of 5 and a perimeter of 20? They discovered that the larger perimeter didn't always yield the biggest quantity. With Flipgrid, students can create video responses that their classmates can view.
I am doing the Would You Rather Cheez-It challenge. I would rather have it with a perimeter of 20 and a length of 5. I drew a square, and each side has 5 as a length, and width, because 5 plus 5 plus 5 plus 5 equals 20. I also made a diagram for the other choice, which would have been a length of 9 and a perimeter of 22. I did 9 plus 9. I did 9 and 9 for the length, and 2 plus 2 for the width, because 9 plus 9 or 18 plus 2 or 4 is 22.
For the Cheez-It challenge, I chose P equals 20 because I get 25 pieces instead of 18. Thank you for watching.
The next challenge included a discussion on whether you would rather have a rectangular bedroom with a length of 20 feet and a perimeter of 58 feet, or a length of 14 feet and a perimeter of 56 feet. Even teachers joined in on the conversation.
I would choose shape B because it's bigger. But for shape A had an area of 180 feet. It's a rectangle. And how I got that is I multiplied 20 times 9 equals 180 feet. And then I did for shape B, I did 14 times 14 because it's a square, and I got 196 feet. And that's how I got my answer for shape B. So shape B is bigger.
Hey guys, I decided to do the 2 different bedroom sizes problem. So I drew out the bedroom that was 14 feet long and had a perimeter of 56 feet. And I found out that it was a square bedroom, and it was 14 feet on each wall. So then I drew out the other one because I wasn't sure I wanted a square bedroom. That one had the walls that were 20 feet long. After I did the math, I found out that it would only be 9 feet wide. And I actually decided to go with the 20-foot long and 9-foot wide bedroom because then my boys can play basketball. We can put a basketball hoop on each end and they can play basketball in there. I think that'd be fun.
As shown in the videos, it is important for students to discover the relationship between fixed perimeter and different areas. Encourage students to explore this concept by building 2 rectangles with a perimeter of 30, with one rectangle having the largest area possible and the other having the smallest area possible. Students discover that the more elongated the rectangle is, the smaller the area. As the rectangle becomes closer to a square, the overall area increases. In the previous task, students were able to find the unknown side lengths of a rectangle when given the perimeter and the length of one side. If the perimeter is 56 and 2 sides are 8, I can simply subtract 16 from 56. The remaining sides have a total length of 40, so 40 divided by 2 equals 20. Students can also find the unknown side lengths of other shapes. The missing side would have a length of 2 because 2 plus 2 equals the total length of 4.
Go ahead, Dawn.
The way to figure out the number over here is to just do 5 take away 3, which is 2.
Wow, great. Now that we have all of the sides figured out, can we figure out the perimeter? How do we do that?
We add up all the numbers on the sides, like 5 plus 5 is 10, and 10 plus 2 is 12, and 12 plus 3 is 15, 15 plus 3 is 18, and 18 plus 18, 26.
So the perimeter of this shape is 26. Can we write 26 in the middle of the shape? Great job!
In this example, we have a regular octagon. Each side of the stop sign has a length of 6 inches. What is the perimeter of the sign? If all of the sides are the same length, then 6 times 8 equals 48 inches. In this example, we are given the perimeter without the length of any of the sides. Since the square has all sides of equal length, we can simply divide 40 by 4. The sides have a length of 10. For additional real-world application, the book Spaghetti and Meatballs for All by Marilyn Burns encourages readers to find the optimal design to seat 32 people at a banquet-style dinner. As guests arrive, they all have their own ideas about how to rearrange the tables. The party becomes a cheerful confusion of rearranged tables and chairs. Students then work to develop a design that seats as many people together as possible, while saving space and using the fewest number of tables. The real-life context helps students link area and perimeter. For additional tasks and resources, please visit Unit 4 in the Georgia Frameworks.